All right, Chapter 2, Section 4, Graphs of Functions. You will need graph paper, so make sure you pick up some graph paper, either in class or, stop at the store, the dollar store or something like that. Graphs of functions. It is much easier to analyze the relationship between a function's two variables by looking at its graph, rather than by its equation, or even than by its ordered pairs. The graph of a function is the graph of its ordered pairs. Graph the function by plotting points. All right, it says graph f of x equals x squared subtract 2 using integers from -3 to 3. Now, I'm sure in your book, sometimes in the graphing part, it tells you which integers to use. Please use the ones they tell you to use. And then use the graph to specify the function's domain and range. All right, now I'm going to say, because we already did tables, to get this table, just use the TI-84. Hopefully you have one or have access to one. So for the table, use TI-84. All right, so X, my function is f of x equals x squared subtract 2. If you don't have a TI-84 and you don't have a calculator that's going to do this for you, well, I mean, you can do it by hand. To get your y's, all you do is you're going to substitute in, right? It's telling me to go from -3 to +3. -3, -2, -1, 0, 1, 2, and 3. All right, again, if you don't have a graphing calculator, just equals parentheses -3 squared subtract 2. This is 9 minus 2, or 7. Or go into the TI-84 graphing calculator, type in y equals x squared minus 2. I could look at the graph if I want. Got my window is goofed up. That's okay, I don't really need it. And I'm going to look second table. All right, it's telling me to go from -3 to +3. So I'm going to copy down those values. 7, 2, -1, -2, -1, 2, and 7. 7, 2, -1, -2, -1, 2, and 7. Again, you can set this up. Doesn't take that long to set up. And this is what you would be doing if you do not have a calculator. And then you can check this. You can check your y's. All right. Now we're going to plot these ordered pairs. It's looking like this 0, -2 is my vertex because I see the symmetry here. So x is 0, y is -2. And then I've got a +1, -1. I can use the axis symmetry, if you remember that from Alg 2. When x is 2, y is 2, 2, 2. Axis of symmetry. When x is -2, y is 2. Yep, it works. And when x is 3, y is 7. Axis of symmetry. There we go. I've got my dots. I can now draw my parabola. try not to go too far past the last point with your graph, because that would indicate a stretch or a shrink. We'll be talking about that at some time when we do transformations of functions. The directions also told us to give the domain and the range. We know from this way to that way, left to right, is my domain. And there are no elements that would not be found on the graph of this function, so the domain is negative to positive infinity. However, when I look at my range, I do have a low point. I have a minimum point. That minimum point is right here. And so my range, my y values, are going to go that way, right? And so my lowest point is negative 2. So I'm going to turn my paper, and I'm going to say my range starts at negative 2, including it with a bracket, and goes to infinity. Okay, so in your homework, you'll have to give a table, graph, give the domain and range, I'm sure. If you have any questions, you know what to do. Ask in class, post on the homework discussion. All right, next page. All right, at the top of the page. Consider the graph of the function in figure 2.27. This diagram right here is figure 2.27. And it's asking us to tell what a closed dot versus an open dot versus an arrow, what it indicates. So if I look at this, you know, and I can zoom in for you if you like. I do see right here that I have an open dot, and I do see right here that I have a closed dot. I do not see any arrows, at least not at this point. All right, so what does the closed dot indicate? Well, closed dot indicate the graph stops at this point, and the point belongs to the graph. Stops there and it belongs to it. It's included. It's shaded in. Open dot, sort of the same thing. It's definitely telling our definitive stopping point, but it is also telling us that it does not belong on that function. So an open dot indicates the graph stops at this point. And the point does not belong to the graph. An arrow, well, an arrow doesn't mean the same thing as a dot. An arrow indicates, you tell me, I'm thinking I'm hearing some of you tell me that the arrow indicates that the graph goes on indefinitely in the direction of the arrow. And if you said that, you are correct. Yay! All right, the graph goes on, doesn't stop, indefinitely. In the direction of the arrows. So some of you may have noticed that on previous tests or quizzes, if you didn't have arrows on your graph, I took points off. And this is why. Because if you do not have an arrow, you're indicating a stopping and that the thing doesn't go on. And so arrows are important if the function is continuous. All right, this is where a function is not continuous because it stops. This is a function, a passive vertical line test. All right, the next part of the notes here on this page 2. It says, use the graph of the function to answer the questions. What are the function values of f of 4 and f of 0? Now, remember, just like before, f of something really means f of x, right? This is f of x. So when we're looking for the value of f of 4, we want to know what is the y value when the x is 4. All right, so I'm like, f of 4 equals, well, I have to use the graph. I have to look at where the x value is 4. And then I have to look at the, the line part or my graph. And I have to say, well, where on the graph of this function is the ordered pair 4 comma something? And that would be this point right here. Yeah? This point right here. Here's where x is 4. And I look to see what the y value is. The y value is 1. So f of 4 equals 1. F of 0. F of 0. Well, f of 0, I'm looking where the x value is 0. And that's going to be found right here. And so the value of f of 0 is negative 1, because that's the y output. Okay? These right here, the 4 and the 0, those are x's, and these are y's. All right, those are the y values given the x values. Kind of like evaluating function when you get an equation, but only this time they're giving you a graph. What is the domain of f? Well, the domain of f means, this function here is function f. What's the domain of it? Well, that's all which values again? The x values, yes. And so, folks, when you're looking for the domain, you have to say, all right, on the graph of this function, what's the first x value that shows up on it? Well, that's 0. And what's the last x value that shows up? That's 6. So all the x's found on the graph of this function are those from 0 to 6. Right? So I know it goes from 0 to 6. Now I need parentheses and brackets. I have a closed dot where x is 0. That's a bracket. And I have an open dot where x is 6. That's a parenthesis. What is the range of f? The range is the y values. Okay? So you have to look. What is the lowest y value? You're on this axis now. What's the lowest? So I'm like, this is lower than that. So it's going from negative 2. And what's the highest y value? It's positive 2. All of these y's are found somewhere on the graph of that function. And so I'm going to say my range goes from negative 2 to positive 2. Folks, please put this in increasing order. It doesn't make sense when you do it backwards. The number line, I get you're going top to bottom, but you should be going negative to positive. All right, negative 2. Am I including a y value of negative 2? I am not. There's an open dot. Folks, this ordered pair right here, if it were on the graph, would be x is 6 and y is negative 2. Negative 2 is not part of it, so it's a parenthesis. Positive 2. is right here at this point. It's a closed dot, and so that's a bracket. Okay? So if you have questions, please let me know. I can't help you unless you tell me you need help. So when you're looking for domain and range, you're looking farthest left, farthest right, just kind of sort of like we did on the circles. And then all those values in between are going to be found somewhere on the shape of that function. All right, the last part of this section of the notes. The zeros of a function, zeros, are really the x values for which f of x equals 0. All right, and soon coming up, your book is going to talk about zeros and roots and intercepts. They all mean the same thing. We want to know, what is the value of x that makes the function be 0? The y-intercept in function notation is f of 0. Why? Because the ordered pair for the y-intercept is 0, something. And that's why on all the tests and quizzes, I wanted you to write your ordered pair for y-intercepts, so that you know f of 0 means it is the y-intercept. Okay? So this is the value of your y-intercept. So now, on the graph of this function in figure 2.28, what is the actual value of f of 0? Well, I'm looking for where x is 0, and where am I hitting the graph of this function? Right up here at a y value of 3. Folks, the y-intercept has coordinates 0, 3, or f of 0 equals 3. There's your y-intercept. So function notation for y-intercept is f of 0. Question for you. A function can or cannot have more than one x-intercept? Well, if you look at the diagram to the right, ask yourself, does this graph pass the vertical line test? And you're like, yeah, it's a function. So can I have more than one x-intercept? And you say, why, sure I can. I've got 1, 2, 3. So a function can have more than one x-intercept. All right, right? Because, you know, if I look at these ordered pairs, this is -2, 0, 3, 0, 5, 0. The y's can be repeated, just not the x's. The final question here. A function can or cannot have more than one y-intercept. And you have to say, it cannot. If it has 2 y-intercepts, it's not a function. It fails the vertical line test. And you'll have the same x being paired with 2 different y's. All right, your homework for this part of the section is on page 228, 1 to 21 odd, and also take a look at number 25. If you have any questions, you know what to do. Have a great day.